Good morning. My name is Gabriel Nambila, and this is my literature review 2 for my Advanced Geospatial Analytics class. So, the article I decided to cover for this review is measuring the quality of life in the city of Indianapolis by the integration of remote sensing and census data. And as you can see on the map, that show which area we're focusing on, where all the census data are gathered, and we particularly try to focus. A particular study area is Marin County in Indianapolis. And so the methodology that we use throughout this paper, the data that we use throughout this paper is they use remote census data and they use 2020 target census data and create a workflow where they could integrate those two type of data to create an index, or I would say a score of quality of life. And so the way they did it is they pick 20 between 10 to 13 variables, and that will factor into these equation to determine a score for the quality of life. And one of them was population density, housing density, green vegetation, impervious surface, temperature, median household income, median family income, per capita income, percentage of college graduate, median house value, median numbers of room, percentage of family under poverty, and unemployment rate. And as you can see, each of them were given a score, how they correlated to others. So on these matrices, you can see, for example, PD, which stands for population density, and HE, which stand as house density, has a strong correlation, and that's why the correlation is positive, which tend to tell us that the high population density equal high housing density too. But also we can see there's some negative correlation throughout the matrix, and so that was one of the basic brick that we use to build these framework model. And for example, if we take temperature and MHV, which stands for median house value, we can see that, for example, temperature and median house value has a negative correlation. On this slide, it kind of show the architecture of the analytical procedure. So we're gonna start. So first, we got the remote sensing data ETM. So we use band 1 through 5 and band 7, and which contain the green vegetation and surface fraction. And we use the ATM plus band 6, which contain the surface temperature. And so when we join those two data, we can aggregate them into a block group. And on the other side, from a census data, we'll get a census block group, and we'll get the socio-economic variables. And so now on the left, we have the aggregate block group, and on the right, we have the socio-economic variable. And then when we join them together, we can create a factor analysis. And with this factor analysis, we can get correlation like we see it on the previous graph. And from those correlation we can create factors, and from those factors we can create a quality of life index, and from that quality of life index we can create a distribution, a regression analysis. And so first, in this first figure, we can see that the first factor that will pick here were the economic index, and you can see that most of the green area are located near downtown, which makes sense that the most wealth is concentrated near around downtown, around the city of Minneapolis. And the negative correlation for the economic index is kind of the outskirts, which is the less the neighbor with the less money or economic index. On the next graph map, What we pick is the environmental index, and we can see that the environmental index again is like near downtown, where it most likely to see where they try to take care of the vegetation. And then on the rest, again on the outskirts of the city, that's where we see a change in color. And if we go back to a graph, we can see that there's a negative correlation between housing density and vegetation. And so, again, everything is based on each other. And so, based on all these different factors, so we went from the first, second, and now third map. The third factor that was picked in this area is crowdness. And so in this one is a little bit different compared to the previous two map that we seen. On this one we can see that it's mostly green outside of the area, and then it's red near downtown, which tells you that downtown is more crowded than all those other neighborhoods because everyone will be located close to where everything is happening. So that's why the crowdness factor is so strong here around downtown area. And as you go further from downtown, you become green in more spacious a more open area. And you can even see by looking at the map that the smallest block tend to be the one in red because it might be a neighborhood or an area where a lot of people want to be at, but then the rest is just open area. So, and lastly, when we condense and bring all those different factors together, so the crowdness, the environmental index, and the economic index, for this example, we can get what is a synthetic quality of life index. And so, after bringing all those different factors together, we can realize that the quality of life the quality of life index is better around downtown area, and that's why it's green. And with all the different factor and correlation that we see throughout the data, it explains a lot that people living near downtown will have a better quality of life because first they have a better index, they have a better economic index, they make a lot of money, and second, they live in a good area, and third, they have a lot of things happening there. And for this quality of life index, there's multiple factors that can be taken into account, but for this specific purpose, only a few were taken. And so, to recap, um, the methodology that was used in this paper about the quality of life to develop the a quality of life score were first we had a remote sensing data which were pictures, and then second on the other side we had the census data. And so once we have those remote sensing images and census data, we can join them in a workflow that let us discover insight and correlation about data. And once we have all of that, we can aggregate all of this data and create a quality of life score and find correlation, for example, between vegetation, population density, income index, and housing price, and even more to other data. By reading this paper, I learned a lot, and honestly, it was an interesting use of remote sensing data and geospatial analysis because it kind of bring the two together to make a decision process and develop a quality of life score. And I truly believe that the same methodology and the same let's see if I can bring it and the same architecture that was used here can be used again for a different city like Houston, Texas, or Austin, Texas, to also create a quality of life index. And throughout this entire paper, what I like the most is how GIS was used as a tool for decision making. And by using it as a tool, it kind of helps us get deeper insight on what is good or what is not. And in this example, develop a quality of life index. and the result on that was to give us a quality of life score for the city of Minneapolis and to understand how the population behave. And in this particular case, we can see that the highest quality of life is around downtown and sometimes a little bit around the outskirts too. And so this was Gabriel Nambila for advanced geospatial analysis. Thank you.